Hi, this is Rheanna and I did Lab 6 and my partner Lawton did Lab 15, the ideal gas law. Her abstract concluded that a gas is a state of matter that is characterized by neither a fixed shape or a fixed volume. Her introduction included that the ideal gas law combines Boyle's law, Charles' law, and Gay-Lussac's law, and Avogadro's law to describe the relationship amongst pressure, volume, temperature, and number of moles, and that the mathematical equation for this is PV equals nRT. Her materials included the glass test tube, the pneumatic trough, the plastic or rubber tubing, the side arm aluminum flask, the ring stand. Her guiding question was that how can the value of R for the ideal gas law be accurately determined inside the laboratory? Her procedure included that they gathered the materials in order to form the water displacement. They put 20 milliliters of hydrogen chloride inside the aluminum flask, and then they put 0.86 of magnesium into the flask and recorded the change. They kept the amount of hydrogen chloride the same and increased the amount of magnesium once and decreased it once. They repeated this for 3 trials. The results included, for trial 1, the before water volume was 710 and the after was 400. The amount of magnesium before amount was 86 and it remained 86. The amount of hydrogen chloride also remained the same, and the temperature drastically increased from 303.4 to 368.4. In trial 2, it included that the starting water was 410 and the after water was 370 milliliters. The amount of magnesium and hydrogen chloride remained the same, however, the temperature decreased. For trial 3, the start volume was 375 and it decreased to 230. The amount of magnesium and hydrogen chloride remained the same. However, they didn't record the temperature for the before. However, they did record it for the after, which was 362.4. She included her cross-cutting concepts, which include the importance of identifying the causal relationships, which is because it helps us identify an accurate procedure and valid results. Her error analysis was that air may have escaped during the lab, and they may have included experimental error. Her method in order to collect the data was the water displacement method, because it was more logical in order to do it in this method. Her conclusion was that they had to design a lab in order to calculate the number of moles by generating a specific number of moles at a gas room temperature and then measuring the pressure of the volume of the gas. And they had to test and evaluate and then refine their method. Her method was that her method allowed her to decide a number that was the amount of moles.
Hi, my name is Lawton. I will be presenting Lab 6. Today, it is not my lab. I am speaking from their terms. Their guiding question was, how does changing the volume or temperature of the gas affect the pressure of that gas? Their claim was, as you increase/decrease the volume or temperature, the pressure of the gas does the same. So, for their materials for their lab, all they basically had was, they had the gas pressure sensor, they had the temperature sensor, the sensor interface, the syringe, the aluminum flask, the single hole rub stopper, the beaker, the hot plate, and the ice. So, as they presented it, it's the procedure in 2 parts. The first part, they change the gas pressure in the response of the gas part. They do the apparatus for that part. And in 6.2, they change the gas pressure in the response to change in the temperature of that gas. So they have to add heat and ice. So in their conclusion, basically was, their conclusion was, as you increase the volume or temperature or the pressure, that gas does the same. So, in the lab.